Okay guys, what we're going to look at now is multiplying and dividing algebraic fractions. Okay, first we're going to just go back a little bit and look at theory A and just look at simplifying fractions. Okay, and this is really part of the division. Okay, so for example, if we have something like, let's say 22ABC divided by 11AC. Okay, you need to remember that what this means is we have 2 times 11 times A times B times C divided by 11 times A times C. Okay, and what we can do here is we can look at where there's pairs of something. So if something's on the top and the bottom, then we can look at cancelling them out. Now, there's two important things about this. One, we can only do this if there's only a multiply in between them. Okay, if you see any pluses or minuses in this, in between things, okay, you could have negative. Okay, -2 would be fine. But if any of these are plus instead of times, if there's no times in between, then you can't do it. Okay, the other thing is that I want to discuss the reason why we do this. Okay, so here with this 11 and 11. Okay, let's look at that first. You can see it's the same on the top and the bottom. There are multiplication marks in between each one. The reason we can do this is because 11 divided by 11 is the same as 1. So what we're actually doing when we cancel something is we're actually replacing it with a 1. Okay, so that 11 divided by 11 becomes 1. All right, next to it, we have A divided by A, and A divided by A, A is equal to 1. All right, and here we have C divided by C, and C divided by C is equal to 1. Okay, so what all of these mean is that we can replace these pairs with 1s. So what we get here is we get 2 times 11 divided by 11 is 1, times A divided by A is 1, times B times C divided by C, which is 1. Whoops. Okay, and all those 1s, we don't bother writing them. We don't write 2 times 1 times 1 times 1. Those times 1s just mean it stays the same. Okay, so what we're going to end up left with is just 2B. All right, so if you see those pairs, you can do this. Now, you've got to be careful because some people seem to think that if I have, for example, let's say 35 out of 45. Okay, some people go, oh look, there's a 5 on the top and the bottom, so I can cancel it and replace them with 1s. Except this is definitely not true, okay, because there's no times in between the 3 and the 5. This is not 3 times 5 divided by 4 times 5. It's 35 over 45. Okay, so you can't do that. Instead, you have to write it as a product of its factors. You have to factorize. Okay, so 35 is 7 times 5. And 45 is 9 times 5. Yeah, that was right. Okay, so again, on the top and the bottom we have 5 and 5, and they can be replaced with 1s. So what we end up with is 7 over 9. Okay, now I did say that sometimes it's different where there's a plus, if there's a plus or a minus. Okay, so for example, if we had 2A plus 6B over 2A. Okay, now some people here go, oh look, 2A over 2A, I can cancel it. All right, except again, this is not possible because what we have here in the middle here is this plus. Okay, and that changes things. All right, actually, we need to do what we did up here. In the step before it, we actually factorized. Okay, so we changed it to 5 times something. Now here, we're actually going to factorize again. Now that you guys have, well, you guys will have done a bit more than this now, but what we actually do is you need to make sure that anything you cancel is in all 3 terms. Okay, later on, you'll understand more about factorizing and that will change things, okay? But basically, you need to think of this as 2 times A plus 2 times 3 times B, okay, that's the 6B, over 2 times A. Now, you can only cancel something that is in all 3, okay, because of that plus. So you need to divide all terms by 2a. So you've got a 2 here and here and here. Okay, therefore we can cancel. Okay, but the a is only able to be cancelled from the first term, not from the second one. Therefore we can't cancel the a. Alright, so what we get left with is a plus 3b over a. Okay, remember those are being replaced with ones, so if they all disappear, you need to leave a 1 behind. Okay, so you've been asked to do 22 as well, and 22, you need to do this before you do the adding or subtracting. Okay, you'll see that once you cancel some things, it will all be easy. Alright, the next thing, as I said, the original point of this video was to get into multiplying and dividing fractions. With multiplying, it's easy. So multiplying is really simple. Okay, with multiplying fractions, you just multiply the top, or multiply we're going to use the correct terms, the numerators, and multiply the denominators. Okay, and this is how we multiply a fraction. It's the same with normal fractions as with algebraic fractions. So if we have and then obviously, sorry, one more step, simplify. Never forget the simplify at the end if possible. Okay, so for example, if we have 3a over 6, let's not make it 6, 3 over 5b times, let's go, let's think, what can I do to make this interesting? 10a over 7b. Okay, so we've got this one. Alright, so we said multiply the numerators, that's step 1. So we get 3a times 10a over, multiply the denominators, 5b times 7b. Okay, I'm going to work across the page. You know I normally want you to work down, but I want to keep this as simple as possible here. Okay, so 3 times 10 is 30. A times a is a squared over 5 times 7 is 35. B times b is b squared. Now, you guys should be able to recognize here that these two numbers can be simplified. That's why our last step is always to simplify. Okay, so we're going to do that. So 30 is 6 times 5 times a squared, and 35 is 7 times 5 times a squared. So always do that simplification step. Here we have 5 divided by 5, which is just 1. Alright, so we end up with 6a squared, oops, that was supposed to be a b here, 6a squared over 7b squared. Okay, now division. Let's use the same numbers. So 3a over 5b divided by 10a over 7b. And you might also see this written as 3a over 5b divided by, and usually they'll put brackets, 10a over 7b. Okay, this is what we're going to do now. Now, hopefully you remember from first year that when you divide a fraction, what we do is we take the reciprocal of the second one, the reciprocal. And what we mean when we say take the reciprocal is flip. Okay, so invert it, we turn it upside down. Okay, so take the reciprocal of the second one, it always has to be the second one, okay, so the one that's on the bottom in this case. Alright, and then we change the symbol to times. Okay, so what we're going to get here is that this is equal to 3a over 5b, remember, leave the first one the way it is, times 7b, we need the reciprocal, over 10a. Okay, let's have a look at that. Multiply them now. We just multiply the numerators, multiply the denominators. So 3a times 7b over 5b times 10a. Okay, 3 times 7 is 21ab over 50ab. And remember, as usual, the last step is to simplify, and you can see here we have a over a and b over b. A over a is 1, b over b is 1, so we can replace those, which gives us just 21 out of 50. Okay, and that can't be simplified. Alright, so let's just write those steps down. So for, what did we have here? Dividing, we flip the second fraction, change the sign to multiply, multiply the fractions, okay, and you're going to use what steps you just did before to do that, and then simplify. So these are our steps for dividing fractions. Okay, now one other thing you have to consider here is that sometimes you might have something like, and I'll just use numbers for this, 2/3 divided by 7. Okay, so you've got a fraction divided by what looks like just a whole number. Now remember, if we have a number and we want to make it look like a fraction, just divide it by 1, and then now it's a fraction. Okay, so let's go through those steps. Flip the second fraction. So we've got 2/3 divided by 7 over 1. We flip the second fraction, so it becomes 2/3, don't touch that first one, and 1/7. Change the sign to multiply, okay, and then just work through it. So we get 2 over 21 in this case. Okay, and this is how multiplying and dividing fractions work. It's exactly the same with algebra, but you just need to consider the letters as well. Okay, good luck.